Hey Mustangs, in this video we're going to be taking a look at climate change. Now there was so much to cover about climate change that I had to create a second video in order to cover it all. So let's go ahead and take a look at two additional effects of climate change. So, um, one of the major effects of climate change is increased ocean temperatures. Before we talked about increased global temperatures overall, now we're taking a look at the ocean temperatures themselves. This actually connects back to melting ice caps. So as the ice caps melt, less heat is reflected away from the planet because that ice reflects a huge amount of heat away from the planet. So as the ice caps have begun to melt, more and more heat is being absorbed by the oceans themselves. And if you think about temperature, temperature is an abiotic factor, but it can have a major impact on organism survival within an environment. So that's what we're actually seeing with a lot of ocean organisms. One of the biggest ones is coral. Now, a lot of people think that coral are plants. So if you take a look at this picture down below, you might think you're looking at a plant right there, but you're actually not looking at a plant. Coral is actually an animal with a sodium bicarbonate skeleton, and they also have a symbiotic relationship with algae. So when you look at coral, it has a mutualistic symbiotic relationship with some algae, and that is actually what gives them the color that they have. So all those beautiful colors that you see, I always think about Finding Nemo when I think about coral reefs and stuff like that. All those beautiful colors you see are mostly due to the algae that they have a symbiotic relationship with. Now, that algae is extremely sensitive to temperature changes, and it cannot survive if the ocean temperature gets too warm. And that's what we actually see happening right now. So all over the planet, we're seeing many coral reefs begin to die, because if the algae dies, remember that symbiotic relationship, it's a mutualistic relationship, they're both benefiting from it. So when the algae dies, the coral eventually dies too. Now, we know algae has died when you see this. So right here to the right, here's a healthy coral reef. On the right, we call it coral bleaching because when the algae dies, it's the one that gives the coral its beautiful colors. You see this white color, the skeleton basically of the coral reef instead. So we call that coral bleaching, and that's how we know coral reef is dead or dying. Now, from 2017 to 2019, 50% of the Great Barrier Reef, one of the most well-known coral reefs on the planet, 50% of the coral reef actually died due to coral bleaching, the death of the algae there. So these increased ocean temperatures are affecting coral and many other organisms. And even if you just look at coral by itself, coral is extremely important because about 25% of marine organisms call coral reefs home. So if coral reefs go, many organisms are losing their homes. Their habitats are being destroyed. Their niches, their roles are being altered and changed. So ocean temperatures have a huge impact on not just coral reefs, but many organisms as a result of these increased temperatures. All right. Now, this last one is ocean acidification. And I'm actually surprised that scientists don't spend more time talking about ocean acidification. They focus a lot, and even politics focus a lot on the overall global temperature changes. But ocean acidification is a really big deal. So basically with ocean acidification, it comes down to the fact that a large portion of the carbon dioxide that goes up into the atmosphere, the carbon dioxide that is produced by um, burning fossil fuels, about 30 to 40% of that carbon dioxide actually dissolves into the ocean. Now, again, we're putting way more carbon dioxide into the atmosphere as it is. 2019 alone, 33 billion to 37 billion tons of carbon dioxide put in, and about 30 to 40% of that is absorbed into the ocean. Now, that's actually a good thing because there would actually be way more carbon dioxide up in the atmosphere, but it's bad because of what happens once that carbon dioxide gets into the water. So if we take a look down here at this chemical equation, carbon dioxide and water, what's going to happen is when they react together, they're going to form carbonic acid. That carbonic acid, the hydrogens come off, and you wind up with a hydrogen ion and bicarbonate. Okay. Now, these hydrogen ions are connected with pH. The more hydrogen ions there are, the more acidic a liquid is. So we're basically creating, by producing large amounts of carbon dioxide, we're causing more hydrogen ions to be released into the ocean and making it more acidic. Now, what that does is it makes it more difficult for shelled organisms to make their shells. Because if we take a look here, in order for an organism to make their shells, their calcium bicarbonate shells, they take calcium and carbonate, and they basically put them together. But you have competition here. These hydrogen ions actually pull the carbonate away to form more bicarbonate. And of course, the shelled organisms can't use that to make their shells. So a huge number of organisms are having difficulty making their shells. Um, and then as time continues on, if we don't change things, what we might see happen is the ocean becomes so acidic that it actually starts to dissolve the shells of these creatures instead. So the shell's actually being dissolved by the acid in the ocean. Okay. Now that's definitely going to be a big deal because it's not only going to affect these organisms, but it's going to have ramifications throughout the entire food web. So we know that when you disrupt one organism, they're not just by themselves. Everything's interconnected. So these guys having a problem with their shells is going to have impacts on other organisms around them as well.